kind of give me a thumbs up. I want to give a great round of applause to give to every speaker. Let's give him a great round of applause.
Two lines. I'm pregnant. I mean, she's pregnant. I mean, we're both pregnant. We're both pregnant. That's you guys probably experienced that. There's probably some people who are pregnant here. They are. We already know. And maybe if you plan on getting married, sometime you might get pregnant too. And that would be, if you're a girl, you would be the one who is carrying what we're going to talk about right now, which is my topic, is embryonic and fetal development. We're going to talk about the development happening during pregnancy. Why is this important? Why should we talk about this? Well, it tells us how we all began. We were all once in there. We were all once swimming around. And not only that, it helps us grasp a better view of the orderly, complex structure being that we are. And it will also increase our value, not by what we can do, but simply by the kind of being we are, a human being. These are the main points that I will talk about. First, I will introduce to you the beginning of life. Then we will talk about the process of embryonic development. Then we'll talk about the process of fetal development. And last, it will be my pleasure to tell you this wonderful story of this surgery inside the womb before she was born. Her name is Sarah Marie Switzer. So, as for my first point, the beginning of life. According to any leading embryology textbook, the textbook I used was called Human Embryology by William J. Larson. All life begins at conception. From the time an oocyte, which is an unfertilized human egg, and a sperm cell meet, when the sperm cell penetrates the unfertilized egg, it's called fertilization. Fertilization creates the first human cell, which is called a zygote. And now a zygote contains 46 chromosomes, 23 from the mother and 23 from the father. It contains metabolism, just like you and I, growth, it keeps growing, cells keep dividing, that's why cell reproduction and reaction to stimuli. A neat thing about the zygote is that it already determines your genetic code. Like, it has chemical instructions that will fill over 500,000 printed pages. And that includes all your hair color, your eyes color, the way, how you're going to be, how tall you're going to be, how weird your nose is going to look, and your personality as well. Everything is in there, your full personhood and your full height and your full color. It hasn't been developed, but it's all been determined. In time, the zygote will divide into the 30 trillion cells that make up the human body. And that includes 12 billion brain cells that form over 120 trillion synapses, or connections, like we saw with Julio's presentation. So, in Darwin's age, the zygote was seen to be something very simple, like a microscopic blob of gelatin or something. But in our age, in an age of scientific enlightenment, we know this is one of the most ordered, complex structures in the entire known universe. So theologians and philosophers can debate over the meaning of life, or the purpose of life. But it's an established fact that all life begins at conception. Now let's talk about embryonic development. At 21 days, your heart was already beating. What was it beating? It was beating your own blood type, obviously. That blood was pumping through there. And if it was different from your mom's, you had your own distinct blood type. Now we go into 6 weeks. At 6 weeks, your nervous system was already in place. That means you had recordable brain waves. The brain and spinal cord were there. And along came with that the pain receptors. Now, one interesting thing, as you as an embryo didn't have at 6 weeks, was pain inhibitors. You developed those 30 and 32 weeks after the gestation. So, what pain inhibitors do is they kind of numb the pain so we won't feel that much pain. But the embryo here doesn't have these inhibitors. They get them 32 weeks after. So one can say they feel more pain than we do at this point. And another interesting fact is that your mom probably didn't even know she was pregnant at this time. Because you were so small, swimming around there. Now let's talk about Fetal development. Most of these things I got from a book titled The Tiniest Humans by Robert L. Sossom. At 3 months, you had your own, well actually that was at 10 weeks. Your fingerprint was shown around 10 weeks, but that's 2 weeks or more, so we just put it into the 3 months. You can also suck your thumb. You can also smile and kick and punch and laugh. Well, not laugh, but your personality was starting to show as well here. And all your body systems were already in place. At 4 months, you learned how to breathe, and you had the ability to cry. Learning how to breathe was, obviously you weren't breathing oxygen, you were practicing with the amniotic fluid that you were floating around with. All the stuff around there too. Because, you know, you don't get a rest from there, so that's what I mean. But if you needed to, if you had to breathe oxygen, you could, because you already practiced with the amniotic fluid. Learning how to cry, what that meant was that you had already, your vocal cords were already developed, and you had tear ducts as well. Now, I'm going to tell you about the wonderful story that I shared, that I talked about, that I introduced. It's called The Story of Baby Sarah. Baby Sarah, at 5 months, was diagnosed with spina bifida while she was in the womb. And spina bifida is like a dislocation of the spinal cord that can cause damage to, either they can become paralyzed or things can go up the brain that can cause hyperpalamus. I can't pronounce that word, but it causes damage to the brain. So what the doctors suggested to the parents of baby Sarah, their term was to use a genetic termination. But the parents didn't want to do that. They valued Sarah's life. They were in love with her already, that they named her Sarah Marie Switzer at that moment. So they wanted an alternative from this doctor. So they did research, and they found out that there were some doctors who did surgery for people in the womb. And so they went on through with it. It was an experiment because this is very recent, very new, that people don't even know. And so they were taking a risk. They were taking a risk for baby Sarah and for the mother as well. But they wanted, you know, Sarah to live without spina bifida. So this is what you see. This is a surgery. They took the uterus out, and they cut up on the uterus. They removed the amniotic fluid. They corrected spina bifida to baby Sarah, and here you see them sewing back the uterus, and that's baby Sarah's hand, saying like, "Thanks guys, I'll see you in 2 months or something," because she was. Oh, and by the way, according to Life magazine, the doctor holding the hand said she's going to be very beautiful. And she, 2 months, almost 2 months after baby Sarah was born. Baby Sarah was born 9 months premature. And here she is. Right now she's about 8 years old. So, it's okay. If we are in truly serious care about children, these are the most vulnerable, most innocent children who deserve our utmost protection and care. In words of Dr. Seuss, after all, a person's a person, no matter how small.
Question!
Go ahead.
Where'd you get your diagram?
These ones?
These ones. This big one.
Oh, this one right here?
Yeah.
Oh, I borrowed it from a community pregnancy center. I did.
Christmas present. Another question! So how did you get interested and fascinated about the topic? And I ask in all respects because you're so well versed in it. I'm almost thinking in a sense that you want to either be a doctor or you want to deliver babies, or is this just a topic that fascinates you?
Yeah, I want to get into obstetrician.
Oh, you're well on your way.